What's up, guys? I'm Kyle from Vanover Customs. Welcome back to our Lion 32-inch build video. If you haven't seen the first video, check the card up here in the description. That video talks more about why we went with this lathe and some of the pros and cons of this specific lathe. In today's video, we're going to jump right into getting to work. We're going to start by getting the area around the lathe cleaned. It's just been accumulating junk for the last year. I'm going to move the lathe more to the center of the room so I can work around the machine, and then we'll start by stripping the badges. I want to get all the badges sent out to Tom Utley so he can get his work on that started, and then we're going to come over here to the top slide. There is a little bit of slop in the top slide. I don't know what the measurement is, but I'm fearing that we're going to either need to make a new nut or address the shaft. And if we've got to order an Acme tap or do anything, I want to jump on this first, so that way there'll be plenty of time if we've got to order any parts, so we can try to keep the project moving along. So let's jump right into it. It's kind of ironic, this machine is still sitting on the machinery skates that I brought it in on. Before I bought this lathe, I purchased these Hillman 15-ton dollies, and these dollies are super expensive. I bought them lightly used for like a third of what they cost new, and they are very, very useful. Machinery skates are really expensive, but if you move machinery a lot, it's completely worth it. I have a couple of the cheaper ones that don't swivel and just have four wheels, and those things are terrible. These things are really nice because they actually swivel, and they have like a roller chain, which is really nice, and then they lock into position. All right, we're going to remove this nameplate here. I'm going to send all the nameplates, or at least some of them, to Thomas Utley of Vaughn Industrial. He's going to be remaking these. These are mostly functional. This, it's fine. It's just a thin piece of aluminum with a print. But I really want to make sure that this is legible for the next 20 plus years. So I'm going to get a new one of these remade, and it's going to be done in thicker aluminum with ink fill. And it'll have a lacquer finish so that it's super durable. Obviously, it will look nice and be easy to read. That's the most important thing. So I'm going to get these rivets removed and then pop it off. There's a number of ways you can remove these guys. We're not saving this, so I could probably just tear it up. But the method I'm doing here is I'm just trying to create a flat spot on the top, and then we'll drill them out and kind of go from there. This hopefully saves as much of the plaque as possible. There we go. That method, I do have one rivet over here that's a little pesky because I didn't get it perfect. Trying to save as much of this as possible in case I had to reuse it. The thing with coming in there and prying these up is you break the corners, that kind of stuff. So drilling these out is a little better than prying on them. This one on the corner I'm going to have to work. There we go. It pulled out fine. But the corner is kind of bent over. This one's actually not too bad. but if you just kind of pry underneath them, you can kind of break this area around here, and in case you do have to reuse it, you know, I just am extra careful just in case. Kind of looks like these rivets are aluminum, possibly. Removing this tag should be fun. The outer ring should come off pretty easy. The inner ring, I might have to figure out how to take this handle off to get it out. These rivets are aluminum, which is kind of nice. There she is. Perfect. In an attempt to minimize damage, I'm using these flat Nip-X pliers. All right, well, these handles come off. These could be screwed in or either pressed in. So we'll try this. If they're threaded in, this should get it out. So you tighten them together like a jam nut. It just occurred to me, if I bring these together, I bet I can just get it right off here. Look at that. Duh. I don't know about how I'm gonna get this one off, but at least we got that guy off. And luckily I don't have to take the knobs off. I can just align them and slide them out. Oh, it's real close. That's what you call engineering right there. Boom. The exact amount of clearance needed to pop that off. We got all the tags off. This is just a shot to show you what they look like before we get these remade. Some of them I'll probably keep. Some of these smaller ones, they're actually in really good shape, and I'm sure they're gonna be pretty expensive to recreate the graphics. Mainly I'm concerned about this one, and maybe some of these more basic ones on the front. Some of these other ones are small and in an inconsequential location, but we'll just see. But here's what we're working with before. All right, we're ready to remove this compound. 19mm wrench. We got 4 screws, or nuts rather. Looking forward to using the jib crane here to make life easy. Just gonna sling this up and move it right on over to the bench. Now I'm not sure what kind of work we're gonna do on this compound. It seems like it's pretty tight, to be honest. I mean, the whole lathe seems pretty tight, but there's not a lot of backlash. And to be honest, especially on a bigger lathe, I bet it's not really used that much. Probably doesn't have a lot of use. And in that case, it probably doesn't have a lot of wear. So if it's fine, we're not gonna touch it. We might take it apart and clean it and inspect it. See, this nut's a little, it's minor stuff, but we're gonna make sure when we go through this, we make sure all the stuff is working perfectly. So if you ever have to take this off, you can just zip them off by hand once you loosen it. Now there's no really place to sling it in the front, but what I'm gonna do is I'm gonna advance this so we have a little overhang. We got that slung. Let's get our jib crane over here. All right, that seems pretty safe. Looks pretty clean under there, to be honest. We're gonna get this over to the bench. Just got it on some pig mat. Perfect. And I'm kind of curious what this weighs, so I'm just gonna measure it with the crane scale here. Talk about a compound, 150 pounds. Not bad at all. Not that you can't work on this stuff without a crane, but when I got the lathe, I actually didn't have the jib. And since then, I got the jib installed, and it's just much safer to move this stuff around. I did it before without it, but it's just nice. Your back's good, it's safer, it's better for the machine, you're not dropping it. It's just good all the way around. All right, so we're gonna leave this guy here and go over to the top slide and take that apart. The next step here is gonna be to remove this top slide. Off camera, I went ahead and just took the DRO off, the scale on this back side, so it'll be easier to get this off. Now I have no idea how to remove this. Unfortunately, being a European machine, there's not a lot of data on this on vintagemachinery.com as far as manuals. And I've seen the Lion manual for this machine, and it's pretty bare bones. It doesn't really go over how to disassemble this. So I'm just gonna kind of mess around with it. A lot of these lathes are very similar. Like on a couple of the lathes that I've done, you disassemble a nut back there, and you can either run the whole thing off the back, or you can take the front part off and undo the nut and run the whole thing off the front. We're gonna try to take it off the back first. There's like a collar back here. It looks like if I undid it, I'd be able to screw this and slide it all the way back, but this is gonna be a little bit more experimental. First step though is I'm just gonna get this cleaned up. It's pretty gummy, so I'll bring you back once I get it cleaned up a little better. All right, I got the top slide cleaned up. We're gonna start by removing these giant Gibbs screws. That might buy us a little bit of room. There's two of them, one on either side. I'm guessing one's gonna be pushing the gib, one's gonna be pulling the gib. There we go. I think it's slid out the front, possibly. The beautiful gib. All right, we're gonna start by removing this collar back here, or nut, or whatever it is. I'm guessing it's gonna be metric. Let's try M5. That looks about right, okay. And looks like this might just spin off. All right, yep, it's spinning off. I'm actually gonna, there's like a slot in here. So I'm gonna come over to the front and back the handle off, and I think it'll back that nut off. There she goes. And this is a clamp here. And it looks like it has a certain position. So I need to figure out a way to mark that position and then take this bearing block off. It kind of looks like a taper attachment, but I don't think it is. It's kind of an interesting way to do it. Anyway, we'll mark or measure or do something, and then I think loosening these two screws will allow this to come out. All right, we went ahead and scribed just on here with a scribe here just to mark this location. And it kind of looks like these are hexes, but it's kind of hard to tell. Need a Jimmy DeResta pick in here to, oh, nope, they're pins. Interesting. They look like they're tapered pins, which is interesting because if they're tapered pins, they shouldn't be loose like that. How much you want to bet that you could advance this forward 6 inches and get 6 more inches of travel, or vice versa? That would be kind of cool, huh? And if these are tapered pins, it means that I don't have to mark this location because it's going to be fixed. Let's pop out this other tapered pin. It's a very interesting design. Well, that was easy. Didn't take much force. And I bet this is going to slide. Yeah, it's loose. Very interesting. Now it looks like there's possibly 2 additional pins. Yeah, the holes definitely are smaller on the bottom. Okay, very interesting design here. Okay, somehow, I don't think it's a split block, but somehow I'm betting that this now will just kind of slide back. Let's try this. Okay, let me operate the front, see what happens. A very interesting design. Let me get my brass mallet and see if I can scoot that forward. This still seems to be captured. All right, let's try something different here. I'm not sure what this is here, but I'm betting these are the bolts for the nut. And if we can loosen this, hopefully we can just keep the nut captured and slide the whole top off. These are relatively simple design-wise. We're just doing it as we go. Sometimes taking it slow is actually easier on you in the long run. Okay, at least I can get a better seat now. Oh, you know what? The nut does look loose in there. Okay, a little update here. I was messing around off camera. I actually took the front off here. It was super easy. 4 bolts popped off. I was thinking about this. I'm moving it back and forth, and it still seems captured by the nut. And when I'm looking at the top, it kind of looks like the nut may have a boss that presses into the top to keep it positioned. Otherwise, it'd just be relying on 2 bolts, which on a smaller lathe, like my other one, that's all it is. But on a bigger lathe, there might be more pressure, and so it'd be nice to have something a little bit more solid than the 2 holes. And I'm thinking, well, how can I get this off? Because it seems to be captured. Even though the back is loose and the front is loose, I want to just be able to slide it off and have the nut stay in. And I could be wrong, but now that I'm thinking about it, since I pulled the gib out, I have a lot of room on the side. I bet that I can get some straps under here and lift this off, and hopefully these press fits will just stay in place. So I'm not sure. That's kind of what I'm thinking, so we're gonna try that. Before I do that though, I'm gonna kind of come in here with a pry bar and lift up and see if I see any movement in these spots. This kind of looks like a reverse flathead. It's really strange. But yeah, I'm gonna try that first and see if we get any movement there. I actually have a screwdriver right here. Oh, look at that, okay. That's a little proof of concept there. So I can't slide it, but I might be able to move it up. So what I'm actually gonna do, a little crazy here, how do we lift this? No real way to strap it. And I would love to see these while I'm lifting, but I think what I'm gonna do is I got a huge magnet. I'm gonna throw a magnet on here and gently lift and see if I can get this off of here without breaking anything. All right, here's a magnet. I'm gonna be careful not to scoot it. Just set it down. And we have to kind of angle it as we lift it off. And I'm gonna be gentle. I don't wanna break anything here. It's not like I can just grab this part from the store. But I bet that I can just lift this off just based on what I'm seeing. And this is a situation where the magnet, if it works obviously, comes in real handy because I don't know how you would rig this. I'm sure there's a way, but this just makes sense to me. And again, gentle here. I don't want to rip off the ears of the casting. So we're just gonna go slow. Okay, like there, I'm hitting something. I think it may work if it comes off at an angle. Okay, there we go. I don't think I'm gonna be able to lift it straight off. There's just not enough room in the dovetail, but it looks like I might have dropped the nut, or I'm real close. So I'm gonna get in there with a pry bar. Our nut's just kind of hanging at an angle. I'm gonna get in there and make sure it's knocked, and then I think we'll be able to slide this off. Basically the design, there's like an ear on the nut that catches. There it is, I dropped it, all right? So you do need to lift it, very interesting. I'm gonna let it down a little. You need to lift it a little. There we go. There we go. We're loose-ish there. I'm gonna lower it a little more. There it is. here we go. Dropping this would be a huge sin. I do have faith in this magnet. I've used it many a times. All right, let's bring it over to the bench. All right, we got touchdown. Perfect. That's great. Now I'm guessing this bad boy's got some weight to it. Just kind of curious what those are. Okay, interesting. Okay, so it looks like this is just some sort of a hollow cap. I'm not really sure what for. And then this is an alignment for the nut. Very interesting. We'll go back over to the lathe and take a look at what we got over there. Let's get this cleaned up. I sprayed it with some purple power. That was a mistake. Works really well, but it's water-based. So I just want to get it off of here. All right, so we got a couple things going on here. Let's point out. So the first thing is we have what appears to be some broken tabs. That's what it looks like, at least. Oh, this is not what I wanted to see. That's all right. It'll make an interesting video for you guys. We'll get to that. So I'm pretty sure if I'm looking at this pad here, it slides with the actual like top slide. And it's possible that these are broken, but it's also possible that these are just stops to stop this from coming too far. I don't know that I really love this design here. As the top slide moves, it's kind of like a guard to keep stuff from getting in here, which is good, but it's kind of annoying, the sound that it makes, and it just kind of slides around. So I don't know if something's broken there, but we'll take a look at that later. That doesn't really matter. The more important thing, I'm going to bring you in tighter for this. All right, guys, here's the bad news. We got a lot of wear on this screw. I don't know if you can tell off the video, but it's pretty pointy over here, and it does get better as we work our way down, and it's a lot flatter over here. This shaft or screw is worn pretty bad. The nut has a lot of movement. I don't even want to know, but when I saw it in the handle, it was too much. The lathe overall seems like the ways are in good shape, but this is in need of attention. I'm sure it's original, and this is probably what many years of use has led us to. So we're going to get this disassembled the rest of the way and see what we're working with, but based on what I've seen of this shaft so far, it's got some interesting features. What I'm really hoping for, really crossing my fingers here, is that this shaft isn't metric, but I can almost guarantee that it is metric. And that is going to pose a problem in terms of remaking this, because our other lathe, which we need to make this, doesn't do metric. So we'll see what options we have as far as getting this repaired or replaced, but we're not going to leave it as it is. So I'm going to continue to disassemble this and then move on from there. All right, the other thing that I'm noticing here that I want to point out is the wear here. Now, looking at a lot of older lathes, I've seen a lot worse wear here. You know, running my fingernail across, I do see a little bit of a dip here, maybe a thousandths or two. Overall, it looks pretty decent, but it doesn't look new by any means. Not that I thought it would. So I would really love to scrape this in. I would really love to do that, but we have a couple of things that we need to overcome. First off, I have a hand scraper, which will work, but I'm not that proficient. And most importantly, I don't really have a straight edge that I can use to check this with. I have a 6-foot camelback that doesn't have a bevel or a dovetail, and it's in pretty rough shape. And I don't have a surface plate big enough to check my straight edge. I might be able to check a 30-inch diagonally on my 24-inch plate, so that may work. But I need to acquire a straight edge, and I need to hone in my skills a little bit. But I would really like to just scrape this and check it, and it doesn't need to be perfect, but I would like to make sure it's as flat as I can get it and decently parallel. So that's something we're going to hopefully be able to address but it's going to take me some time to acquire a straight edge and get it scraped in and do some checking, and then hopefully we can revisit this once I get to that point and address this. I'm going to go ahead and get this shaft removed, and I'll meet you over at the bench so we can talk about what the next steps with that are. All right guys, we're over here at the bench looking at the shaft, and let me be honest, this shaft threw me for a loop. I initially thought it was going to be metric, and being metric was going to be very difficult for us to make. So the first thing I did was measure the outer diameter, and it's closer to 30 millimeters than it is any inch equivalent. And then I measured the outside shaft over here, and this is 24 millimeters with a 1.5 pitch. So far I've established this end is 100% metric, and the OD of this shaft in the unworn section is closest to 30 millimeters. So I opened up my machinery handbook and figured out a 30 millimeter outer diameter trapezoidal metric thread with a 5 millimeter pitch made the most sense for this shaft based on my measurements. Now that is not a common pitch for 30 millimeter. 3 millimeter and 6 millimeter are, but that doesn't mean that it couldn't be made. So besides that, I thought that I had a 30 millimeter, 5 millimeter pitch. But what I realized when I looked at the handle was the handle has increments of 400 thousandths on the handle, which means that this is without a doubt actual 5 pitch SAE, not 5 millimeter. And the reason why that's a little confusing is 5 pitch SAE, or American, is very close to 5 millimeter. The direct conversion is a 5 pitch equals 5.08 millimeter. So it's extremely close. So one of two things is happening here to make this shaft kind of interesting. Either A, they're manufacturing this shaft with a 5 millimeter pitch, and they're slapping on this handle, and because it's so close, even though it's not exactly precise, it's close enough to be fine. That's one scenario, or one option. Option two, they're making a metric end on this end, and they're coming in here and they're machining this to a 5 SAE pitch so that the handle matches. Either way, it doesn't matter. They're so close that what we're going to be doing is we're going to be making this in one of the lathes, and we're going to be making it to a 5 pitch, which is great news, because if it was metric, we'd kind of be stuck. So the good news is, regardless of whatever way they did, we're going to be making this to a 5 pitch SAE, and that will match what's on the handle here, which is perfect. All right, I'm going to stop you guys right there. So we're actually going to be making that on the pacemaker lathe. But in order to make this shaft on the pacemaker lathe, what I've had to do is I've had to go into the future and I've had to create a follow rest for this lathe, because I want to make sure that when we take and we make this new shaft, that there's no deflection when we're making our cuts and we're keeping everything nice and straight. So the next video you're going to be watching is a video of me making the follower rest, and then after that we're going to bring you along for the video of making this in the American lathe. I hope you guys have enjoyed the installment of this Lion Lathe project. There's going to be many more videos to come, and stick with us for the next video on the follow rest.